Right, good morning everyone. Today we're going to do two things. I think the first, let me close the door. The first thing we're going to do is we're going to carry on with what we started yesterday, which was a very important step in physical computing. We started hacking, as in, and here in the nice meaning of the word, which is we combine pieces of code, we combine circuits to make a new piece of code, to make a new circuit. And what we want to do today as an exercise is to combine the blink exercise with the button exercise to create a circuit and to create a program where when we press the button, a certain LED is blinking, and when you press the other button, another LED is blinking. So, how do we get on with doing that? Well, we know, as always, we start with our usual principles. So either we have a problem, we have an idea, or we have an exercise, and we try to find a solution. Our problem is we want two LEDs to blink with, depending on a button. So if a button is pressed, it's one LED, and if a button is not pressed, it's another LED. So one of the golden rules that we have is that we have to be lazy and reuse what's there. We know that the blink exercise is one of the examples in the library, and we know that the button exercise is also in the library. So we're going to combine these two. So first, we have to combine two things. We have to combine the circuit, and then we have to combine the programs. Okay? Yesterday I've asked you all to bring in a logbook. How many of you have a notebook with you now? Good, because we're going to use that. It's, as I said at the start of this series of modules, don't move now, later. As I said at the start of this exercise, module, not only I'm going to teach you physical computing, but I'm going to teach you a new mindset, a new way of thinking, because you need, if you want to be very effective at programming, if you want to be able to make a lot of physical computing systems, circuits, and programs, you need to think like a programmer, you need to think like an engineer, you need to think like an electronic engineer. So I teach you this, I teach you the basics, the key, let's say, the key tricks of the trade that will help you become very effective and quite proficient at physical computing. So that's why I'm asking for a logbook where you're going to put notes. That's why I'm telling you all these things, is to help you get there in a very effective, efficient, and actually professional way. Okay, so we know we need to deal with the circuits, and we know we need to deal with the programs. As always, our first rule, golden rule, which we wrote and we have on the Facebook group, is that we have to be lazy. And we all love that, don't we all love being lazy? Which means we take the hint, if you want, is when you have two programs, when you have two circuits and you want to merge them, you start with the most complicated one and then you add to it. So if you have a circuit that has LEDs that have things and then you just want to add the button, you're not starting with the circuit with the button and then you add all the LEDs. You start with the complex, difficult circuit. It's already there, so you can just repeat it, and you know you won't have any problems because you know it works, and then you add the button into it, okay? So we're going to look at the circuits, and then we're going to look at the program. So let's start looking at the circuits. So when we look at the circuits in the Arduino tutorial, and we have here, I'll open a new window, a new tab, so we have the blink, and we have the button. So here is the circuit for the blink, And here is the circuit for the button. They are approximately the same complexity. It's not like one is obviously more complicated than the other. So we can start, let's say we start with the button circuit. And here's the schematic. So what we need to do is a little bit of thinking about what you want to achieve. And that's why we need a logbook, is to help you think and help you put it on paper and help you, because when it's on paper, you can look at it, but your teammates can also look at it and check that you have the right circuit. And it helps you check if everything is all right or not. So, if we look at the circuit for the button, I'll just start with the button because, yeah, why not? We have to start with one of them, and they're pretty much equivalent. We have, essentially, we have the Arduino. We have, from the ground, we have a resistor, so that's our ground. We have a resistor. Then we have our switch, our button. And that then goes to 5 volts. So we can do it like this. So that's 5 volts, and that's ground. And we have between the resistor and the button, we have a connection to pin number 2. Okay? Because we've done this exercise yesterday, because it's on the Arduino website, we're pretty sure that it's going to work, no problem. So we can build this. Okay? I've only rewritten what's there, and we're familiar with understanding how that works. All right. So, next, we want the circuit for the LEDs, which is the one for the blink. So, we go to the blink example, and we can see that the circuit is like this. So, what are we standing on? So we all share the ground, okay? Your ground is always shared. That's one of the golden rules of electronics. So we share our ground, and then out of the ground there's a connection to the LED, and then to a resistor, and then it goes to pin number 13. So we have the ground. So here we have an LED, then we have resistors, and then we have pin 13. But we don't like pin 13. We said we're going to change that. Which pin did we use yesterday? 9. So that goes to 9. Then, because we want 2 LEDs, we're going to add another circuit for another LED. So, same story. We share the ground. We have the LED. We have the resistors. And then which pin did we connect it to? Which one?
Pin 8.
8, okay. Now, what have we done here? We've done this. We put the circuit for the button. We haven't changed anything. Then we added the circuit for the LED as shown on this schematic. And we just changed the pin where it's going to, because we don't like pin 13. Then we did another circuit exactly the same, and we put it to a different pin. We could have put it in the same pin, but then these 2 LEDs will have been like clones. They will have behaved exactly the same. We don't want that, because we want, when the button is pressed, one LED start blinking, and when the button is not pressed, the other LED start blinking. That means if you want to have something doing different things, the easiest way to do that is to put them in different pins, and then you say different things. The Arduino will do different things on each of the pins, okay? So, in theory, this is our circuit, and that's it. We have 2 LEDs, and we have a switch. So, if you want to simplify that into a plain English circuit, we have one LED, we have another LED, and you have a button. Yeah? And what you want to do, when this is pressed, this one blink, and when this is not pressed, this one blink. That's what we want to do. Okay? Right. Next that we've done this, we look at the program. So if we start with the blink program, as we did it yesterday, we look at the loop. There's a setup which is to say, when you have LED built in, that is basically 13. This is a name, this is a variable which is 13. So that's pin 13, but we don't want pin 13, we want another pin. So in the setup, we set up the pin LED built in, which is pin 13, as an output. And we write on pin 13 high, we wait 1,000 milliseconds, we write on pin 13 low, and you wait 1,000 milliseconds. In plain English, that means pin 13 on, wait 1 second, pin 13 off, wait 1 second. That's what it means in plain English, okay? Now, we want to do something else. So, we want to have the button controlling which one blinks. First thing we know is at some point we're going to have to change that to either pin 9 or pin 8, depending on what we want. So that's we're not going to use pin 13 anymore. That's already something we know. Second thing, we need to have a look at the code for the button. And when we look at the code for the button, again, we have a LED in pin 13. We have a button pin, which is number 2, which is what we have there. And in the loop, we have this. We read from the button pin, so we read from pin 2. If it's high, that means the button is pressed, because there is a current going through. If it's high, write on the LED pin high. If it's else, that means it's going to be low, write on the LED pin low. In plain English, and that's why you need your logbook, because you're going to write these things in plain English, so you can think about the logic. That is the key point of any program, of any physical computing project. You need to think. And the biggest mistake 100% of people do, and you've all done it yesterday, you immediately start doing. Think. If you do, with these simple exercises, you can get away with it. But when you go into more complicated projects, if you just start programming and you just start building your circuit, you're going to make mistakes, and then it's going to be a nightmare to debug, and it's going to be a nightmare to fix. So think first. So, in terms of the